line 1 has equation this and line 2 has equation this. So we have two equations and we have to show that the lines do not intersect. So they're giving in the column vector format. That simply means this is 1i, 0j, minus 1k plus lambda and ijk. That's what it means. It's a shorthand form of writing the vectors. So first step should be writing these out in the ijk format. So this should be, so this is 1i plus lambda into I. So that should be 1 plus lambda I plus, this is 0 plus lambda into 1, 0 plus lambda j plus minus 1 plus lambda into 0. This should be minus 1 plus 0 k. Remember, we could have also written this as the column vector format. 1 plus lambda, 0 plus lambda, minus 1 plus 0. It's the same thing, just column vector format and ijk format. This is L1. Now L2 would be, so 1 plus 2 mu I plus 3 plus mu j plus 6 minus mu k. The first thing we do is we form equations by I equals to I, because if they intersect they should be in the same position. So 1 plus lambda should be equals to 1 plus 2 mu, and the equation turns out to be lambda minus 2 mu equals to 0, equation 1, and j equals to j. So here it would be 0 plus lambda is 0 and coefficient of this is 3 plus mu. So that means lambda minus mu equals to 3. This is equation 2. So let's solve this. So lambda minus 2 mu equals to 0. Lambda minus mu equals to 3. If we change the sign for cancelling the lambda and lambda, so this turns out plus mu minus 2 mu is minus mu equals to minus 3. Therefore mu equals to 3. Once we know the value of mu, we can easily find the value of lambda. And so let's put this in this equation. Lambda minus 2 mu equals to 0. Therefore lambda equals to 6. So we have found the value of mu and lambda. So how do you show that the lines do not meet? There are two ways of doing that. Let me show the simpler way first. So the simpler way is for k equals to k. So let's take the coefficient of the final one. So minus 1 plus 0 and 6 minus mu. So the third equation is this. In the third equation, mu should be equals to 7. Now, in the third equation, if we put mu equals to 3, it doesn't really matter because 3 is not equal to 7, so it's wrong. And in the third equation, there is no place for lambda because lambda equals to 6. There is no place to put lambda. So the third equation does not hold true. So in order for the lines to intersect, all three simultaneous equations must hold true. If since it does not, that means the line do not intersect. So you write since all three simultaneous equations do not hold true for mu equals to 3 and lambda equals to 6, the lines do not intersect. This is a one quick way of showing whether the lines intersect or not. Another way would be to actually find the point of intersection and see whether they match or not. If they match, then they intersect. If they do not, they don't intersect at all. So another alternate way would be, so let me put lambda mu equals to 3 here in L2. So if we put mu equals to 3, it would be 1 plus 2 3s are 6 I plus 3 plus 3 is 6 j plus 6 minus 3 k. So when we put mu equals to 3, this is what we get, 7i plus 6j plus 3k. Okay, now let's put lambda equals to 6. If we put lambda equals to 6, this should be 1 plus 6, 1 plus 6i, then 0 plus lambda, 0 plus 6j, plus minus 1 plus 0. So minus 1 plus 0, that means minus 1k, So 7i matches, 6j matches, but this one doesn't match, minus k. So hence the line do not intersect. That's the other way. Question number B. We have point A which lies on L1 and lambda equals to 1 here. So let's put lambda equals to 1 in L1. So at A, lambda equals to 1. So it turns out to be OA. Remember, the line is always in the position vector format. So OA equals to 1 plus lambda, lambda is 1, I, plus 0 plus lambda, lambda is 1, j, plus minus 1, k. So OA equals to twice I plus j minus k. So we got A. Then at the point B, mu equals to 2. So let me write it over here. At B, mu equals to 2. That means OB equals to 1 plus mu is 2i plus 3 plus 2j plus 6 minus 2k. It turns out to be 3i plus 5j plus 4k. Let me check with the equations. So this is 1 plus 2 mu, 3 plus mu, 6 minus mu. So that means this would be 1 plus 2 to the 4. This should be 5. Okay, so 5i plus 5j plus 4k. Now what we have to do over here, we have to find the cosine of the acute angle between AB and the line L1. First of all, we need to find what AB is. So since we know OB and OA, we can write therefore AB equals to, by the position vector rule, position vector of B minus the position vector of A. So it turns out to be, let me write this down in the column vector format. 5i is 5, 5j is 5, 4k is 4 minus 2i j minus k, and this turns out to be 5 minus 2 is 3, 5 minus 1 is 4, 4 minus minus 1 is 5. So this is AB, the direction vector. Now in order to find the angle between the line L1 and AB, this is what it looks like. So it would be, this is L1 and this is AB. We know A lies on the line L1, so this is A, so this is B. So this is the angle we're looking for. Remember the rule. The rule is cos theta equals to direction vector of L1, let me call this D1, dot direction vector of AB. AB itself is the direction vector, divided by modulus of the direction vectors. That's it. So now let's check what's the direction vector of L1. So it's right over here. This is the direction vector of L1. This is 1 1 0, meaning I plus j plus 0k. That's the direction vector of L1. So let's start. So hence cos theta equals to, so direction vector of L1 is I plus j plus 0k, dot direction vector of AB is 3i plus 4j plus 5k, divided by square root of 1 square plus 1 square plus 0 square, square root of 3 square plus 4 square plus 5 square. And we have, if you multiply the coefficient of I with I, that would be 1 into 3 plus coefficient of j into the coefficient of j, that would be 1 into 4 plus coefficient of k is 0 here, coefficient of k is 5 over here, divided by square root of 1 square plus 1 square is 2, square root of 3 square is 9, 9 plus 16 is 25, 25 plus 5 square is 25, that is 50. So that means 3 plus 4 is 7, this is 7. Square root of 2 into square root of 50 is square root of 100, that means 7 by 10. Do we have to find angle or do we have to find the cosine of that angle? So find the cosine of the acute angle between this. So that's it. We don't have to find theta. We have to find the cosine. So cos theta equals to 7 by 10. In this question, we have the vector equation of a line given, vector equation of L1. And we know that 2 points lie on this particular line and we have to find the value of the constants. First of all, let me define once more what does it mean that L1 has vector equation. What does that mean? Think of this. If you have a line and suppose this is a point and this point is something, let me call this point x1, y1, z1, and suppose you know that this point, the line that passes to this point, it is also parallel to another vector. Let me call this vector d or d1. Now when they say the vector line L1, the line L1 has vector equation this and that, it simply means that this point over here, 8, 12, 14 is this point, this starting point x1, y1, z1, and this value over here, the direction vector, it is this one, the direction vector d1, and the line is basically an arbitrary point, any point. Let me call that arbitrary point x, and its position vector, let me call that position vector OX, is given by R. That is the vector equation of L1. So L1 is basically this, an arbitrary position vector. You can call this a universal position vector, and it is solved using the basic rule of vector triangle. So if you have a triangle like this, so this is O, let me call this point, let me call this A. So OA plus, we don't know how long this line is, but we know they have the same direction vector d1. That means we can figure out the vector AX by multiplying it with any arbitrary constant lambda, or we can use mu, with the direction vector d1. So the total rule of the vector would be OX equals to OA, that's the clockwise direction, plus AX. That means OA plus lambda of the direction vector. So this is what R is. R is a universal position vector. Now the position of this point x depends on how far it is away from the initial point, which we are calling it A over here, how far it is. That means the longer it is, the value of lambda would be changing, it would be increasing. So for a particular point, the value of lambda is fixed. So suppose if lambda equals to 1, the point might be here. If lambda, and the position vector would be here, and lambda equals to 2, lambda equals to 3, lambda equals to 4, and on it goes on. And for a particular point, the value of lambda for every coordinate is fixed. So that's how this is working. So we can get back to this question. So the first thing is, let's write out the universal position vector, this one, in the IJK format. So this is going to be 8 plus lambda I, 12j plus lambda j, 12 plus lambda j, then 14 minus lambda k. So this is the universal position vector. So what this means basically is that we have some sort of a line where this is the position vector, suppose OX, and this line passes through the point 8, 12, 14. This is the point 8, 12, 14, and it is parallel to a line whose direction vector is I plus j minus k. That means this line, let me call this point W. So this point Wx would depend on this direction vector multiplied by some constant. So we will know how long this line actually is. So this is a universal position vector. When they say point A lies on this line, that means they're actually giving a new position. They're saying, so there is a point A over here, and they're giving us the coordinates of that point. That means we can write OA equals to 4i plus 8j plus ak. Now if this point is a universal position vector and this is a specific position vector for the point, so we know the value of lambda would be specific. The value of lambda would be the same for each and every coordinate. So we know this. So what we can do, we can equate the two vectors. So we can just write for I equals to I, we can write 8 plus lambda equals to 4, therefore lambda equals to minus 4. Done. We can also do the same with j equals to j. 12 plus lambda equals to 8, therefore lambda equals to minus 4. But we know that lambda is already equals to minus 4 and we want to find the value of the constant a. So now we can do for k equals to k. So this is going to be 14 minus lambda, and we already know lambda is minus 4 and this is equals to a. So a would be equals to 18, therefore a equals to 18. Done. Again, now we have to work with OB. So, and OB. So OB is BI plus 13J plus 13K. So we can write for, now since I is unknown, the coefficient of I is unknown, we're going to start with J. So let's start with j equals to j. In that case, the coefficient of j is 12 plus lambda. This is equals to 13. Therefore, lambda equals to 1. That means even for k, the lambda is going to be 1. 14 minus lambda equals to 13. Therefore, lambda would also be equals to 1 because for a particular point, the value of lambda is fixed for that particular point. So now we can compare I. For I equals to I, we can write 8 plus lambda. 8 plus lambda is 1 equals to coefficient of I here is b. That means therefore b equals to 9. So we have found the values of a and b. So answer, a equals to 18, b equals to 9. And the next question, this is a bit irregular, so you have to remember how this particular question is done. What we know right now is the universal position vector. So L1 is basically a universal position vector. You know what that is. And if we write this is L1. So this is a universal position vector. Now they're talking about another point P. So we don't know what that is. And they're saying the point P is such that the position vector is 90 degree to the line L1. That's what it says. Given that the point O is the origin and the point P lies on L1 such that OP is perpendicular to L1, it's 90 degree. It's important to note this special rule. When you have two lines perpendicular, so this is the perpendicular line rule. If you have two lines perpendicular, then direction vector dot direction vector of the other line is always 0. If two lines are perpendicular, then the dot product of the direction vector is 0. So this is very important, and we are going to use this rule. So the dot product of the direction vectors, that's equal to 0. Now, how do we do this sum? First of all, the universal position vector L1 is given by this. Let me copy it. So what does this mean? This means this is the universal position vector, or any point that lies on the line L1 has this position vector, meaning OP is also equal to this. So this is also the same as OP. So we can call this any unknown position vector including OP. So we can just use this as OP. Remember that. If we can use this as OP, then what do we need next? We need to know the value of lambda. For a particular value of lambda, we can find the point P. So the dot product should be with the direction vector. So the direction vector OP is OP itself. So this is OP. Let me write this in the column vector format. It's easier to write. So OP should be 8 plus lambda, 12 plus lambda, 14 minus lambda, dot. Now the direction vector of L1. If you remember, the direction vector of L1 is what is written after the scalar quantity. So this is lambda. Whatever is written here, that's the direction vector. That's the vector with which this is parallel to. So the direction vector of L1 is going to be I plus j minus k. So this is going to be I meaning 1, j meaning 1, minus k meaning minus 1. That's what it is. And this dot product should be equals to 0. So let's do the dot product. So dot product is coefficient of I multiplied by coefficient of I. So that should be 8 plus lambda multiplied by 1 plus coefficient of j multiplied by coefficient of j, 12 plus lambda multiplied by 1 plus coefficient of k, 4 minus lambda multiplied by coefficient of k equals to 0. And this turns out to be 8 plus lambda plus 12 plus lambda minus 14 minus minus plus lambda equals to 0. And we can write lambda plus lambda plus lambda is 3 lambda. 8 plus 12 is 20. 20 minus 14 is 6. So 3 lambda plus 6 equals to 0. Therefore, lambda equals to minus 2. So for the point P, lambda equals to minus 2. So let's find the value of the coordinates. At lambda equals to minus 2, so we can find OP. OP equals to 8 plus lambda. That means 8 minus 2 is 6i. 12 plus lambda, 12 minus 2 is 10j. And 14 minus lambda, 14 minus 2 is plus 16k. So P has coordinates 6, 10, 16. Question number C is just find the length of OP. That means the modulus of the position vector. So question number C would be OP modulus equals to square root of coefficient of I whole square 6 square plus j whole square 10 square plus coefficient of k whole square 16 square, and it turns out to be square root of 36 plus 100 plus 256 equals to, so 100 plus 36 is 136 plus 256, that is 392. Now how to find this in the SERT format? So if we divide this with 2, we get 190, and 14 square is 196. So this is going to be 14 square into 2, 14 square root 2.